All right. Hello, we're Team Interactive Academy, and this is our final presentation. This is our team. Our advisors are Shirley and Mo, and our client is the Inanimate Dallas Research Group. Our metrics matrix are client requirements, innovation, and gameplay/interactivity. Interactive Academy uses kinesthetic learning and new media storytelling techniques pioneered by Inanimate Dallas to create an experience on WebGL aimed at sparking STEAM interest in middle school students by way of game development subjects. This is especially relevant given the current world we live in, with students and teachers forced to adapt to online learning. This combination of techniques in a remote learning prototype aims to hook students' attention and keeping their interest in the content. So, what is Inanimate Dallas? It has been a long-standing series of interactive digital novellas. This series harnesses text, visuals, and sounds. It chronicles the experiences of aspiring game designer Alice as she travels around the world with her parents. She incorporates tech and her design aspirations by using her backseat player throughout the series, creating short animations and games. Inanimate Dallas' world has a tendency to be dark, scary, and confusing to her. However, her imaginary friend Brad, who seemingly lives in the player, is always there to help her out of her predicaments. Our project serves as a potential side chapter to the series by drawing upon Alice's experiences from past episodes and echoing the general tone of the series thus far. Research has shown that kids often don't get interested in STEAM subjects because they're complex and dense. In addition, kids are exposed to more and more media, and vying for that attention is a challenge. By tapping into gamified learning, STEAM concepts can be explored via the game development process, giving students opportunity to participate in these subjects in a tactile way. Our client tasked us with weaving the RICS framework, which stands for Read, Imagine, Create, and Share, into our experience. As a result, we decided to spark student interest in STEAM through game development concepts. Here's our demo video.
Our experience starts as other episodes in the series do, with an introduction from Alice. We learn that Alice has received a new backseat player and is going to transfer her data over. However, as the transfer occurs, something goes wrong. Alice immediately checks on Brad, who has been a digital companion of hers throughout the Inanimate Alice series, only to find that the data transfer corrupted him as well. Now, Alice dives into the digital world of her backseat player in search of Brad. In this chapter, players search the room for objects necessary to solve puzzles on the room's computer. Code blocks are used to highlight programming logic, while mind fragments harken back to Alice's experiences in past episodes. Programming puzzles require the correct placement of code blocks to fill out the logic. Here, Alice is tasked with filling in the details for a recovery tool to scan through corrupted files. Solving this puzzle recovers Brad's own memory and gives Alice and the player the ability to chat with him to learn more about what occurred. Chapter 2 greets us with a barren, textureless landscape. We learn that the data transfer affected this area as well. In order to make this area whole again, Alice needs to apply textures to these digital objects. When Alice enters the gallery after applying her first texture, the world responds to her contribution and unlocks a new mode for creativity. The texture editor not only allows for players to change the colors of any texture, but highlights hex codes as a way to connect how art and technology can be intertwined. From here, the player is free to customize the landscape as they see fit, thereby breathing new life into the area. Players are then given the functionality to save their creations to their computer.
Before halves, we finished building chapters 0 and 1 and conducted some playtests. Now I'll hand it over to Lawrence, who will talk about our progress after halves.
Thanks, Karen. For Playtest Day, our major takeaway was that we can improve instruction and guidance within our experience. We also received positive feedback and saw that students appear to be more engaged with the content due to the interactivity and story, while the perception of programming as a daunting subject decreased. With our playtest day data and feedback, we continued iterating on chapters 0 and 1. First, we increased visual polish. Before, some players had difficulty placing code blocks where they wanted. To improve usability, blue highlights now show where said code blocks will be placed. Visual effects were also added to amplify story moments, such as using the glitch effect to exemplify corruption and using particle effects to better sell the data transfer. We further applied more educational tactics to Chapter 1. After reading some papers, we learned about the concept of scaffolding. In short, when scaffolding hints for children, each subsequent hint should be more detailed than the last. We implemented this method in the code block puzzles by having 3 hint states: no hints, normal hints, and highlighted hints to punctuate the solution. With this methodology, students are allowed the freedom to experiment and learn at their own pace while having help if need be. With Chapter 2, we knew we wanted to focus on art since this could better reflect the create and share aspects of the RIX framework. We landed on texturing since this works as an action within our digital world, is another great game development topic to explore, and imbues interactivity within the story of the chapter. We utilized hex codes as a fusion of art and technology within the texture editor. Players can change the colors of the textures by using these hex codes. This fusion is reinforced by having players enter the code manually instead of just displaying it. In this way, we use interaction to show that art can be represented in a programmatic fashion and further push that Steam connection. With Chapter 2, the focus shifted from linear puzzle solving into one of more customization and creation. In order to keep the player connected with our goals, we utilized Brad as more of an encouraging guide who responds to Alistair's questions and observations. Next, Jamie will dive into more of the programming within Chapter 2.
Thank you, Lawrence. In Chapter 2, we add a new feature submenu to the inventory system. When players click on a pattern, it will show the submenu with 5 copies of this pattern. Players can save different color strategies on these copies for later texturing. To edit the pattern, texture merge shader was used by the preview area of the texture editor. It loads in color 1 and 2 and shows what the pattern will look like when players adjust the colors in runtime. There's a color placed in front of the preview area to capture the edited pattern as a render target when save button is pressed. This render target will be passed to a distort shader to texture an object in the outside world. Distort shader is implemented to texture 2D images of a 3D space and fake the 3D look and feel. It has 3 main functions to simulate the viewing angle of an object: rotation, distortion, and density adjustment. You can see in the middle that the texture aligns with edges after rotation, and then, after applying density adjustment, the part of the texture which is more distant from the player gets denser. After doing all this, it overlays the result with the original object sprite to keep shadow information. This is another example when apply distort shader on the ground. On the left, the picture shows the original texture without shader used. After distorting along x-axis, it has a look on the right. And then we adjust density along y-axis of the texture and get the final result. After playtesting Chapter 2, we realized that more patterns are needed to better reflect a natural and outside world. So we finally chose A to B gradient pattern. The picture on the right shows the outside world after applying it on the sky and tree. And now I'll hand over to Sally to talk about art.
Thank you, Jamie. We were building a point-and-click adventure wherein the scene served as a user interface. We wanted to design a gallery space that was abstract and visually compelling. So we drew inspiration from modern art gallery images for the structural design and lighting. The models had a mix of solid and emissive textures. The walls were high fidelity to act as contrast to the canvases and also draw the user's attention towards the interiors. Volumetric fog, mesh lights, spotlights, and area lights were used to achieve realistic interior lighting and indirectly navigate the user's eye. We visualized this texture editor as a basic medium that facilitated create and share. So we lay our design of a blocky sci-fi hand with colors flowing down into an RGB pool. Coming to the outside world, it was custom modeled to be set in a corrupted digital backseat player. So the mountains were inspired by digital signals, the clouds represented data clouds, the floating bit trees inspired by code blocks in Chapter 1, and the rocks were modeled as message icons since chat was an important aspect of our experience, And lastly, location, a repeated motif in the inanimate Alice episodes, was embedded as a natural element. The environment was textureless, affected by the data transfer, so only the gallery was textured by reusing the textures from the gallery interior. A combination of directional lights was used to keep the lighting consistent between the gallery interior and this outside world. Area lights and spotlights were used to further distinguish the gallery from the textureless environment. Sherry will now talk about the changes that we made after softs.
Thank you, Sally. So we received a lot of valuable feedback from soft, and we mainly focused on 2 of them. The problem got most often mentioned is that in Chapter 2, we didn't provide our players with enough instruction. Hints were mostly stated in the chat with Brad and Alice's monologues. So if our players missed it, it would be hard for them to follow through. Also, as Jamie mentioned before, we added a submenu for more variants of the textures. This might sound like a good idea on paper, but in fact, it introduced a new different interaction pattern that we never taught our players in the previous chapter, which made our players more confused in-game. So to solve this problem, we used the hint system in Chapter 1 and added general hints throughout the scene. If our players get lost in the game, they can always hover their cursor on the question mark and get a brief hint on what their current goal is. By implementing more hints and instruction in this manner, we were able to remove the restriction put on certain features which hindered our players' freedom. We also removed the submenu for the textures and went back to the easy and intuitive drag and drop interaction in consistency with the previous chapter. Another topic that got brought up several times during soft meetings is visual clarity. In this screenshot, chat bubbles blended into the background because of the similar turquoise color, and the edges of the corrupted light blue chat bubble was also distracting. So we revised the chat UI a little bit. Now it's easier to tell who's speaking because of the profile photos of Alice and Brad and the new chat bubbles with offsets. We also added a half-transparent background to make the chat content stand out more. Another place where visuals cause confusion is the color UI in the texture editor. The gray mask on the unselected color might cause a color perception bias. Therefore, we get rid of the gray mask and use a highlighting border to tell the players which color is being modified. Last but not least, we increased the line spacing and eliminated the text orphan throughout the whole experience so as to make it more visually pleasing. Next, Rongjia will talk about our summative playtest results.
Thanks, Sherry. For summative playtest, we ended up getting 14 responses. You can see the curve mostly skewed to the left with a decrease in perceived programming difficulty by 8%. Also, this group had a 9.7 increase in interest in programming, which would correlate to 487 middle school students in Pittsburgh. Here are some feedback we received. Students indicated that the changes made our experience more fluid. They also liked the glitching effect in Chapter 1. We have learned a lot through this project. First of all, since there's a lot of ambiguity in the original episodes, we aim to appreciate how ambiguity can spark further conversations. Weakness, however, can also turn into a lack of explanation. Also, we probably should have done more synchronous playtests to gather real-time reactions and thought process, which is greatly hindered by the limitations of COVID-19. A design lesson we have learned was that sometimes things that sounded good on paper didn't actually work, like the submenu Sherry just mentioned. In terms of documentation, we have written a development journal, which outlines our process and serves as an educational reference. Here's our client testimonial.
It goes beyond bringing us closer to the goals. I think it helped us clarify our goals. We learned things that we didn't know that we needed to know.
For me, it's allowed me to see the possibilities of digital narrative in STEM education, but always the questions looped back to the pedagogical implications, how this work could be used effectively in the classroom, how it could help us meet our goals of preparing teachers to use Alice in the classroom. And it helped me clarify my thinking a lot about what the curriculum should look like.
We were in the transition phase between looking at our literacy objectives and moving towards a STEM pathway. And this particular project's given us a lot of opportunity to talk in detail about those STEM objectives and how we can head off in that direction. So it has actually provided that shift for us. It's a good fit for what we were aiming to do anyway. It just takes us and adds a tangent. It adds depth to what we're doing.
Our client plans to use our deliverables for an NSF grant and a Games for Change submission. Special thanks to all these teachers, playtesters, and faculty members, especially John Baylash, who has been providing feedback and facilitating playtesters for us. We are Teamed Interactive Academy, and we are now open for questions.
All right, great job, team. Congratulations. So if anybody has questions, jump right in there and chat or speak up.
Go ahead, Mike. Yeah, I have a question on your scene 2, and I'm curious whether your playtesters thought it was expressive enough to really make beautiful pictures. Do you either have an example of something beautiful that was made and shared that people were really proud of? Or can you talk about that? Was it a scene you can really compose something beautiful on top of?
So we had a couple playtesters that did take a bunch of screenshots of a variety of different scenes. For instance, during Festival, my brother really got into Chapter 2 and spent probably 15 minutes, if not more, like making sure to compose the perfect scene and really playing with the hex codes, playing with color balance to create his scene. He's a little older than our target demographic, but I think that just shows how much he was able to enjoy it as well.
Yeah, if you saved a screenshot, throw it in your blog. I'm curious to look at it.
Definitely.
Yeah. Also, in our summative playtest, we asked a question about how many screenshots that students take, and I think we got our answers range from like 1 screenshot to 6. So if that's equals that.
I got a question. So you guys are making effectively an adventure, a point-and-click adventure game. Any insights into the general playtesting of that? I mean, you mentioned that hard to get the balance between like hints and intentional confusion, right? Did you discover any strategies to like see that or understand that better?
So we were trying to ride the line between a point-and-click adventure game in more of the traditional sense and just going for more of a highly interactive experience that used point-and-click mechanics. And I know for me, I learned a great deal about point-and-click adventure games, and as simple as they are on the outside, there's a lot more complexity behind the scenes that goes into that. I think learning about some of the minutia of point-and-click design could have helped us maybe alleviate some of the ambiguity we found out early on, or later on, I mean.
Cool. Time for one more.
Not a question, but a request. I see the link to your build, but I can't get to it. Can you put that link in your chat, in the chat, please?
Yes. Ranja or Jamie, could you put the link?
Thank you, Shirley, for pointing out that word choice mistake. I'll definitely correct this.
Yeah, so our build is hosted on both the ETC server and our client server. I think the ETC server is going to go away this semester, but it's going to be on the client server. And there's going to be Google Analytics that is going to be embedded. So there's going to be some meaningful data tracking even after we end this project.
All right, congratulations, team. Good job on your final.